All right, this is using parallel lines and transversals. In the previous section, we talked about what a transversal was, and we're actually going to apply this in parallel lines. So, first postulate we have is the corresponding angles postulate. If we have a straight line and then draw a line that is parallel to it, so for example, we have Q and we have P. The transversal T here cuts through, and it actually states that the corresponding angles are going to be congruent. And this is actually something you can kind of model. If you imagine taking Q and literally just moving it up, the transversal. For example, you move it up, the transversal, and Q actually becomes P. The angles 1 and 5 are the exact same measurements. They're the exact same degree measurements. So that's what the postulate states. Corresponding angles are going to be congruent if two parallel lines are cut by a transversal. So we would say that angle 1 is congruent to angle 5. Okay, so this is cool. The measure of angle 1 is 120 degrees. Find the measure of the rest of the angles. So we have corresponding angles, we have vertical angles, we have linear pairs. Well, let's say we have angle 1 is 120 degrees. So if we know that, I can say that angle 1 and angle 4, those guys are vertical angles. So I can say this guy's 120 degrees. Okay, so the other thing I can say is that angle 1 and angle 2 are actually a linear pair. They are supplementary. So if they are supplementary, that means they add up to 180 degrees. So angle 2 is actually going to be 180 minus 120, which gives us 60 degrees. So angle 2 is going to be 60 degrees. And angle 2 and angle 3, those guys act as vertical pair as well. So vertical angles are congruent by the vertical angles theorem. So that is going to be 60 degrees as well. Now, let's look at corresponding angles. In the previous one, we had angle 1 and angle 5 were corresponding angles. So if they're corresponding angles, they are congruent because they're two parallel lines cut by a transversal. That means angle 1 is congruent to angle 5, and in turn, angle 1 is equal to angle 5. And then you can fill in all the rest of them. We have vertical angles here, so that's 120 degrees. Linear pair here, that's 60 degrees. Vertical angles here, that's 60 degrees. And we basically filled in all of the angles just by knowing one. Okay. Next theorem is the alternate interior angles theorem. And it states that if you have two lines cut by a transversal that are parallel, again, we're dealing with parallel lines. In the previous section, we were not. These were not parallel lines. But basically what it states, if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are going to be congruent. And the cool thing is, you can actually show that by the previous slide here. If you notice, angle 3 and angle 6 are alternate interior angles. They're inside the two parallel lines, and they're on opposite sides of the transversal. And I have 60 degrees and 60 degrees. So the measurement's the exact same. So, angle 4 and angle 5. Now we have another pair of angles as well. This pair of angle here, 3 and 6. I'm just making up numbers. Those two guys are also alternate interior angles. Alternate exterior angles. They are going to be congruent as well. So, just like the alternate interior, the corresponding alternate exterior is going to be congruent. So this is one pair of alternate exterior angles, and we say that they're congruent. And again, you can look at the figure, and you can look at this one here. We have angle 7, angle 2. Those are alternate exterior angles, and they both measure 60 degrees. So that's just one possibility. So yeah, alternate exterior angles, those are going to be congruent. The other pair of alternate exterior angles you could have, let's say we have 4 and 6. That's another pair of alternate exterior angles. consecutive interior angles. Well, before I tell you what consecutive interior angles is, let's go and look at this wonderful figure back here that is jumbled with stuff. The interior angles, basically what you're looking at, it has to be in between the two parallel lines, and they have to be consecutive, right next to each other. So they're consecutive interior angles. What do you notice here? We have 120 degrees, we have 60 degrees. What do you notice about those two numbers? What do they add up to? Well, if I look at this, if I add them up, I get 120 plus 60. That means it's 180. Which basically, the fancy word for 180, two angles that are 180 degrees, they are supplementary. So, the consecutive interior angles theorem states that if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are going to be supplementary. So, the measure of angle 3 plus the measure of angle 4 equals 180 degrees. You also have another pair here. For example, this could be 2 and 5. These two angles as well are supplementary angles. They add up to 180 degrees. Okay, so here we go. It says find the value of x. Lines A and B are parallel, so we can use the theorems about parallel lines. All right, so we know that they're parallel. A couple different ways we can do this. I noticed that these two guys are vertical angles. So what do we know about vertical angles? By the vertical angles theorem, they are congruent. So that means angle 4 measures 115 degrees. Okay. What else do we know? Well, if these guys were vertical angles, what about these guys? Looking at these, they are consecutive interior angles. Well, from the previous theorem, consecutive interior angles are supplementary. So we can say, okay, 115 degrees plus x plus 5 degrees equals, supplementary is 180 degrees. We can solve, we subtract 115 degrees on both sides, we get x plus 5 equals 65 degrees. Subtract 5 again, and we get x is equal to 60 degrees. And that's it. So, x is equal to 60. To plug it in, you can plug it in because it's asking to find the value of x, but to actually find the degree measurement, you'd have to plug it into the value of x. But all we were asked to do is find the value of x. So we are done. Here is our wonderful proof. So we have proved that if two lines parallel lines and they're cut by a transversal, then the pairs of alternate interior angles are going to be congruent. Well, we're trying to prove that the alternate interior angles are congruent, so we're proving a theorem, which means we can't use that theorem in the definition. We can't automatically say that angle 1 is congruent to angle 2 because of the alternate interior angles theorem. We're trying to prove that. So we have to start off with given. What do we know? We know that the two lines are parallel. So that's given. Well, what do we know about angles 1 and angles 3? Those are similarly positioned angles. So angle 1 and angle 3, they're going to be congruent. How? Because they are corresponding angles. Corresponding angles we can actually use. Corresponding angles postulate states that they're congruent if two parallel lines are cut by a transversal. Now, what else do we know? Well, looking at this, I see angle 3 and angle 2. They have a particular property. They're vertical angles. So let's look at that and say angle 3 is congruent to angle 2 because of the vertical angles theorem. You can say vertical angles are congruent theorem, vertical angles theorem, either or, it doesn't matter. Once I look at this, I can say, okay, well, angle 1 is congruent to angle 3. Angle 3 is congruent to angle 2. What property states that I can say that angle 1 is congruent to angle 2? Transitive property of congruence. You can just say transitive property. That's fine. I'll know what you mean. So we just did a 4-step proof, or a 4-line proof, that proved that the alternate interior angles theorem is an acceptable theorem. We proved it, now we can actually use it. Here's another one. This is kind of a physics one. We have when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. This is what is called refraction, where light actually reflects off of at different angles within either a drop of water or glass or various other things. For violet light, the measure of angle 2 is equal to 40 degrees. What is the measure of angle 1 and how do you know? Well, looking at this figure, I see angle 2 and angle 1. We have our two parallel lines, one parallel line here, one parallel line here, and here's our transversal here. So what is the position of angle 1 and angle 2? Well, I see they're on opposite sides of the transversal and they're on the interior of those two parallel lines. So I can state, because the sun rays are parallel, angle 1 and angle 2 are going to be alternate interior angles. By the alternate interior angles theorem, angle 1 is going to be congruent to angle 2. And by the definition of congruent angles, you can state that the measure of angle 1 is equal to the measure of angle 2. That's what definition of congruence states. Anytime you go from congruence to equality, that's definition of congruence. So we know that angle 2 and angle 1 is 40 degrees.